Welcome to Newer Math. I'm Jeff Jacobs, and today we're going to talk about factoring expressions. Let's get started. All right, example 1. Factor 20 minus 12 using the GCF. Now, if we're factoring, obviously, we're going to be talking about factors. And if you think of factors, you probably are going to be thinking of greatest common factor. So first, if we're going to factor using the GCF, we need to find the factors of 20 and 12. Well, the factors of 20, you've got 1 and 20. You've got 2 and 10. 3 doesn't work. 4 does. 4 times 5 works. 6, no. 7, no. 8, no. 9, 10, and we're there. So there's the factors of 20. All right, how about the factors of 12? Well, for 12, same thing. 1 times 12. 2 times 6 works. 3 times 4. 5, no. 6, 4, yeah. So those are the factors of 12. What can 12 be divided by evenly? So now, the greatest common factor. They both have a 1, so that's a common factor. They both have a 2, that's a common factor. 3, no. They both have a 4, that's a common factor. Are there any others that are common? No. So 4 is the greatest common factor. Hopefully this is review. What that means is we are going to factor out the 4 from these two numbers. So you can think of this as kind of the reverse of the distributive property. When we use the distributive property, we multiply whatever we're distributing to every term in the parentheses. What we're doing now is we're factoring out, or we are dividing each term by that greatest common factor. So let me show you what I mean. 20 minus 12. Well, we can think of 20 as 4 times 5 minus 12 as 4 times 3. And like we said earlier, we know that 4 is a common factor. That's why I chose that. So what I'm going to do is I'm going to divide that out. I'm going to factor it out. And now I'm just going to have what's left, which is 5 minus 3. So you can think of this as very similar to the distributive property, just kind of in reverse. If we use the distributive property here, I would do 4 times 5, which is 20, minus 4 times 3, which is 12. But we just did the opposite, which is called factoring. Here's one to try on your own. All right, here's example 2. Factor the expression using the GCF. So we're still factoring. However, you'll probably notice that these examples are no longer numerical expressions. Now we're using algebraic expressions. But we do the exact same thing. We're looking for those common factors, and specifically the greatest common factor that we can factor out of the expression or divide out, and then we make those parentheses. So here, if you notice, well, I've got 36W and 9. There is no W here, so W is not going to be part of my GCF. I'm mainly going to focus on the 9 and the 36. And I think, well, what is the greatest common factor of 9 and 36? Well, it's 9, right? So if I think about 36W as 9 times 4W, right? 9 times 4W is 36W, plus, and 9 I can think of, 9 times 1, I am going to factor out that 9. And as you go along, you probably won't have to do this step. Hopefully you'll be able to do it in your head. But for now, let's just write it down so it helps. I factor out that 9. I'm dividing both terms by that 9. That comes out. So what's left over? Well, I've got the 4W plus the 1. And that is factored. And if I want to check it, just do the distributive property. Do the opposite. 9 times 4W is 36W, plus 9 times 1 is 9. So there we go. I am happy with that. Let's look at B. 28x plus 21y. Again, This term has an x, this term has a y. So those aren't going to be part of what I'm factoring out. I'm just going to focus on the 28 and the 21. What's the greatest common factor of 28 and 21? 7. So 28x I'm going to think of as 7 times 4x. 7 times 4x is 28x. Plus the 21y, 7 times 3y. 7 times 3y is 21y. So notice I'm not changing the value here at all, right? These are all going to be equivalent expressions. Nobody's changing the value. We're just changing what it looks like. That's all we're doing. So now let's divide out that 7 from both terms. Let's factor it out. So I've got 7 times 4x plus 3y. And again, if I want to double check, just use the distributive property. 7 times 4x is 28x, plus 7 times 3y is 21y. So I'm going to box that. And let's move on to the last one, which is a little challenging. So now we've got 3x squared and 12x. Well, right away, you probably say, well, the 3 and the 12, greatest common factor is 3. That's not bad. But is there a common factor between the x squared and the x? And if you think, well, what's x squared? X squared just means x times x. And then you got an x. Is there a factor in common? Of course there is. An x. So we are going to factor that out as well. Let me show you what I mean. So we're already factoring out the 3. We're also going to factor out the x. So together, we factor out the 3x. Well, what's left over? If I divide 3x squared by 3x, what's left over? Just an x. And if I check, 3x times x is 3x squared. X times x will give you the x squared. Plus, do the same. Factor out the 3x. 3x times what is going to give me 12x? Well, what's left over? Just the 4. 3x times 4 is 12x. Now we are putting it all together. I factor out the 3x from both terms, bring it outside the parentheses. So I've got 3x. What's left over? The x plus 4. And before I box my answer, let me check using the distributive property. 3x times x is 3x squared. Plus 3x times 4 is 12x. Now I can box it, and I'm done. Here's some to try on your own. As always, thank you so much for watching, and if you like this video, please subscribe.